Good afternoon, everyone. So welcome back to our MMU 3H series webinar, the engineering series. So this is the third day of this engineering series. Today's the topic that we are going to share with you is Nanotech plus you. Today we have two speakers. One is me, Dr. Sin, and the other one is Dr. Lini. Okay. So to start this webinar, I would like to share my screen now. Okay, so today's topic is Nanotech plus you. And then the building that you're seeing right now is actually our Chancery building of MMU, which is located in Cyberjaya. So today's we have two speakers. Like what I've said just now, I'm Dr. C, and then another one is Dr. Li Lini. And then the building that you are seeing in this slide is actually the Faculty of Engineering building that located in MMU Cyberjaya. So let's come to our topic today. The topic today is nanotech plus you. And then nanotech is actually come from the word nanometer. So boys and girls, do you know how small is 1 nanometer? So you can see from the image in the slide, this image is actually our hairs. So as you can see from the hair, from the picture, our hair is approximately 100 micron. So if you want to have 1 micron, you need to slice your hair 100 times. So the slicing is actually according to the diameter. It's not to the length. So be careful. This is the diameter. The diameter of one hair is 100 micron. To get 1 micron, you need to slice the diameter of the hair into 100 times. After that, this 1 micron, you need to divide it into 1,000 times again. Then you will get 1 nanometer. So now you can pick one of your hair and then to look at the diameter now, and then to see if what happened if you slice it 100 times. Then after that, slice again 1,000 times. So you can imagine now how small is 1 nanometer. So 1 nanometer is so small. Is this something that's strange to us? Is this something that's alien to us? No. Nanometer actually is surrounding us. So nanometer happen or occur in the nature. So for example, we see the butterfly. The butterfly wings, when there's a droplet drop onto the butterfly wings, you'll find that the droplets will be repelled or it won't stick on the surface of the butterfly. Why? It's because on the butterfly wings, there are nanostructure on the butterfly wings. So it prevents the water actually stick on the wing of the butterfly. So nanometer actually happen or occur in our nature. Besides, the most famous topic right now, the coronavirus. The coronavirus, the size of the coronavirus is actually 80 nanometer to 120 nanometer. So if you want to study the coronavirus, we need to study nanotechnology as well. Actually, nanotechnology is happening or apply in our daily life. The first example is the sunscreen. So if you buy some product from the pharmacy, you can see inside the boxes, the ingredient. Some of the cosmetic and the sunscreen, they will actually put some nanoparticle inside. For example, the gold nanoparticle, the zinc oxide nanoparticle, the TiO2, or we call it titanium oxide nanoparticle into this product. So to prevent the suns that cause the damage to your skin. Okay. Then another application is clothing. So in Japan, they also have invented some of the pans that will repel the water. So that your pans will actually can prevent from dirt. So the concept of this repellent of water is come from the nanotechnology. Third one is the adhesive, and then the fourth one is the car paintwork. So for the paint on the car or paint on your house or the wall, then there are some of the product they actually apply the nanoparticle on into this paint. So you can have some of the property like water repellent or easier to wipe the dirt. So this kind of property that happen into your paint that is actually come from the nanotechnology. The fifth one is computer. Your handphone now, the processor that is actually making in the handphone is using the technology which is in nanometer. For example, the iPhone 12, the Bionic 14 chipset is actually using the 5 nanometer technology. So actually, our daily life, we have a lot of applications that using the nanotechnology. Also, if you let's say if you use it, you want to change your screen protector of your handphone. When you go to the salesperson, they will also ask you whether you want a product which is have a nano coating or a normal coating. So if you want to have a nano coating, then the screen protector is more can prevent the scratches even better. So this is all the application of nanotechnology in our daily life. But today, what I and Dr. Lini will share with you is the material in nanometer which apply in the energy harvesting. Okay, there are two topics that we are going to share respectively. Me, I will share on the piezoelectric, and then after that, I will give you a example on a small project that you actually can try to implement in your home. How to actually harvest the energy using the piezoelectric material. At the same time, later on, Dr. Lini will actually introduce what is triple electric material, and at the same time, she will actually present you a demo on how to actually create this triple electric nano generator. Okay, so I would like to share my topic now, which is what is piezo material. So the word of piezo is originated from Greek word is piezo and piezine, which means to press and to squeeze. So it means by this material, you can convert the mechanical energy into electrical energy or vice versa. So it means by this material, when you squeeze it or press it, then this mechanical energy will create the electrical energy. However, if you apply the electrical energy into the mechanical energy, apply the electrical energy into the material, then you actually cause the vibrations of this material. So this material was first discovered by Pierre Jacques Curie in 1880. So like what I'm talking to you just now is the direct piezoelectric effect. That effect is when you press the piezoelectric material, you will actually generate a voltage. So one of the example that applying direct electric piezoelectric effect is your microphone. So for your microphone, when you talk, the sound will actually generate the vibrations onto the material. So this vibration will actually convert it into an electric signal. So if this electric signal will actually recorded and then to be produced and saved into your computer. So this is one of the application of direct piezoelectric effect. There's another piezoelectric effect that is applying in the effect which is called reverse piezoelectric. If you remember of this application, sorry. Okay, sorry for some technical issue just now. So I will continue for this reverse piezoelectric effect. There's an example of this reverse piezoelectric effect is the speaker. So like just now, when your microphone, when you speak, you actually generate the electricity. But now the microphone is a reverse effect, which is the electricity will actually cause the vibration of the material. So when you have this vibration of the material on the air, you actually will give you the sound. So this is the reverse piezoelectric effect that we actually apply in our speakers. So now I'm actually want to show you this. You can do it at home, which is build your energy harvester using the piezoelectric material. So let me show you the small video round. So you need the piezoelectric transducer, the diode, the capacitor, the breadboard, and also some wire. So this is a simple energy harvester. So as you can see, we have a multimeter. When we press on the piezoelectric transducer, you can see the voltage is actually increasing. So this is a very simple energy harvester that you can make it in your home. So now you are in holiday, so probably you can buy these devices online or components online. Then after that, you make your own small size project at home. Okay, like what I mentioned just now, material that you need to make this small experiment is the breadboard, the piezoelectric transducer, and then four diodes. So it's four rectifier diodes and one LED. So the diode, let me explain about about the diodes. So the diode that you purchase, that will actually have a gray area. So this gray area will indicate that is a negative or a cathode. And then the side that without the gray area or the gray color is actually represent anode, which is positive. And then you need to create this rectifier by connecting the four diodes together in this circuit. So if you buy the breadboard, if you buy a breadboard which have the numbers and alphabet, then you probably can refer to this chart. So you can create the circuit as shown in the diagram. After that, we need a LED. So to show they actually have electricities that generate. So the long leg is represent the anode, and then the short leg is represent the cathode. To connect the rectifier with the LED, so you need to connect the cathode into this end, and also the anode into the other end. So because the distance is very large, so I actually using the wire to connect them. Then after that, you are connecting the piezoelectric transducer into the system. So you can see in this system, as shown in the video, when I press on the piezoelectric transducer, the LED is blinking. As you can see from the circuit here, there are no power supply. But how the LED can blink? LED need to be light up if only you have voltage across, right? So in this mean, when we press the piezoelectric transducer, this mechanical energy is actually transferred into a voltage or the electrical energy, so that it will light up the LED over here. So that will be a very simple energy harvester. And then you can make it at your home using the piezoelectric transducer. So that's all my sharing for the piezoelectric transducer. So I would like to invite Dr. Lini to share about the Tripol electric nano generator. So we'd like to invite Dr. Lini. Turn on mic.
You want me to share? Yeah, I'm here. Hi, I'm Lini. As mentioned by Dr. Sin earlier, he has talked about piezoelectric. So I will continue talking about Tripol electric nano generator. Let me share my screen. How to change to the full screen? On my side, I already changed to full screen. Okay, wait. All right. Every day we see people walking around here and there. But of course, it doesn't happen today due to the COVID-19 pandemic. But before this, we always see people walking around here and there. Have you ever wondered what if we can collect those energy that we use to walk around and create some electric from it? That is what it means by Tripol electric nano generator. So on this screen itself, you can see the home experiment that I have prepared. This one, just an easy, simple, we call it Tripol electric nano generator. Don't worry, I will go through with you step by step on how to do this. And I'll explain what is Tripol electric and what is nano generator. Let me talk about what is Tripol electric effect. It's something like if you see lightning or thunder, you actually see it, then you hear it. And this lightning, this thunder is due to static that we have. You have charges on the sky, you have charges on the ground. So when they are connected, it creates a lightning effect. At times, when you are trying to open a doorknob, you will feel an electrical shock. That is static electricity. At times, when you take a cloth and you rub it on a glass and a glass rod, you find that there is some static electricity in it. That is because the charges that has been separated between positive and negative. The most obvious will be if you have balloon that you have rubbed a lot and you put it near your hair, you will see that your hair will be attracted to the balloon. That is because they have excess positive charge on hair and you have excess negative charge on the balloon. So when they have two different charges, the opposite charges will attract each other. That is what is meant by Tripol electric. So this is more of materials that you use. That means a different material that we use, two different kind of materials. When we combine them together, they will be electrically charged. when they are separated, which they are in contact. It's the same example that I gave just now. When you have your hair and a balloon, if you're not sure, you can try it out later when you take a balloon, get your parents, get your mom, and say, I want to try out the triboelectric effect, or rather, the more layman words will be static effect. Take a balloon, rub it on a cloth, then you put it near your hair. You will see that your hair is attracted to it. So in physics-wise, what it means is that in our normal daily materials, what we have is electric charge. And this electric charge consists of proton, neutron, electron, and this proton and neutron are all in a nucleus, whereas they are circling around by electron. Electrons are negative charges, while proton are positive charges. So naturally, all materials that we have today have all these charges. But if we rub them against each other, they will be separated between positive charge and negative charge, just like it's shown here. And then if you put them near your hair, you will see that you'll be attracted to each other because the opposite charges will attract each other. That's what it means. So this is another example. If I take what we have on this here on the hand, it's actually a piece of cloth, something like a carpet, which is neutral, positive, negative charges, and a balloon, which is neutral, positive and negative charges. Then I rub against each other. After I've rubbed, they've actually separated the charges. So the cloth will have positive charge, the balloon will have negative charge. So when they are near each other, they'll be attracted to each other. It's equivalent to static charge, okay? Now, what if we can collect this charge and generate triboelectric? It's something like, if I have a handphone, and if I can make it as a triboelectric nano generator, meaning if I put it in my pocket and as I walk along, it's moving, I am moving, and I am generating. So I convert this movement into electricity. So if I convert this into electricity, it's called triboelectric nano generator, or what we call TENG, T-E-N-G. So it's actually a combination of triboelectric effect and electrostatic induction. So want to try out? Do you want to try out? Let me share with you a video on how to do this. I'm going to share a YouTube video. Can you please hold on? All right. This is the real triboelectric nano generator that I have, which I have created. Okay. This I created at home by myself. All right. It consists of that piece of thing, and I tap on it, the LED will actually light up. Okay. So if you look at this, this is quite a simple materials that we need here. What do we need here? Firstly, let me grab two wires. These are two wires, or what we call the jumper wires. If you have a normal wire, you can grab it. If not, you can just grab the wires that is usually used to tie your loaf of bread. Okay, just tear off the gold metal pieces and you'll find there's a small wire in it. You can use that. Okay, that is also acceptable. Then you need an LED, can be any colors that you want, cellophane tape or office tape, a pair of scissors, and of course you need 2 cards or paper card, any paper card will do, and aluminum foil. Aluminum foil is actually a conducting material. That means it will conduct electricity, it will create charges. So you will see that aluminum foil is used there. Let's start with these 2 pieces of cards. I'll cut them to similar sizes. All right, just make sure they are similar sizes so that it's easy for me to tap on it to create the triboelectric effect. Okay, so these 2 pieces, I fold them in the middle so that when I combine them together, then I can tap on it to create the triboelectric effect. Okay, now let's start with this jumper wire. This is jumper wire, we will place it on the card. You can also remove the plastic on the jumper wire here, or just use a normal wire, you will not have the plastic part. Let's start with 1 card. take the aluminum foil, cut it to slightly smaller size compared to the card, the paper card, so that I can tape on it. Okay, so I'm cutting it to smaller sizes, slightly smaller. Use a cellophane tape, put it here. So the wire will be in between the paper card and the aluminum foil. Okay, so the aluminum foil is actually slightly smaller so that I can paste on it. I can cut it smaller if I want to. Then let me grab the cellophane tape or office tape. Let me grab the edges of it. Okay. The aluminum foil is ready. Cellophane tape is ready. Grab the cellophane tape. Stick the aluminum foil on the piece of paper card. It's just a normal card, okay? Any card will do. Stick them together, just like this. All right. Let me cut this part off. Okay, so that I can stick the aluminum foil on the paper card and make sure the wire is in between the two pieces. So these are the two pieces in between and the wire to connect to the LED. Okay, so this is one piece that I have. We'll do the same thing for another piece. Put the wire in between the second card. Put the aluminum foil there. I have to cut, yeah, make sure it sticks together nicely so that the wire will touch the aluminum foil. And then when I tap on it, it will work. Take the aluminum foil, make sure it's slightly small pieces. Cut it according to the size of the card. All right. And then I'm going to put the wire in between these two cards. Okay. Take the cellophane tape, stick the aluminum foil onto the card. All right. Put them together. Just a little bit excess of the cellophane tape so that I can stick the aluminum foil to the card. Insert the wire into it. Yeah. Stick them together. Okay. Make sure the wire is touching the aluminum foil. Combine the two cards together so that when I tap on it, it can move like this. Okay. Then I'm going to use sellotape to stick both of these two cards together, just to make sure they are intact. It will not run out and it can create some electricity. So stick the end of it together, combine them. Same thing with the end of each side. That is one side. This is another side. I'm going to put on the cellophane tape on this side as well. Okay, make sure it is intact so that the electricity created can be seen on the LED. Okay, just putting in the sellotape together. Make sure the cards are intact. Okay, wires are connected. Now I'm going to grab the LED, connect them together. At this point, it doesn't matter whether it's a positive or negative terminal. Okay, I just need to put one terminal to each of the wire. Click them together and we are done. So you can try it out when you tap on it. All right, let's say I tap on it fast enough, you can actually see the LED lights up. Okay, probably you won't see it here, okay, because the daytime is quite bright. It's very bright. So these are the two sets of Tripoelectric nano generator that I have created. So these are the materials needed. So if you really try it out, you can actually see and test it in a dark place. It's actually light up little by little. This is how I recorded the light in a better place. Okay. So what we have done is actually just the LED. LED is here, the wires connected to the LED. And this two pieces are the wires and the aluminum foil, which consists of the clear tape, the aluminum foil, and the paper cut. So combine them together, connect them together, then we tap on it. Then you will see that it is connected to each other. So that's it for my tank, PENG. So what you have seen so far in Nanotech plus you, I think Dr. Sin has also talked about what is nanotechnology. Here is more example where you can actually see a sort of grain is 100,000 nanometer. What we mean by nanoparticles is 1 to 100 nanometer. These days, during the COVID-19 pandemic, we use a lot of enteromicrobial uses. The antibacterial that you have used, all those things, it has the nanoparticles in it. It's supposed to kill the bacteria. Even the sunscreen, the UVA, UVB that you see every day, they are mainly blocking the UVA and the UVB because the wavelength of it is in nanometer. So we need something related to nanotech, nanoparticles to block these wavelengths. On clothes that we have silver clothes, which is the silver color that you see. Sometimes it's antimicrobial and water repellent. The silica that you use on the clothes is water repellent. Sometimes you see your clothes that you bought is advertising that it can absorb UV, something like your swimwear. It's because they have put in some nanoparticles on it. It can actually absorb the UV. Even antiseptic, especially for athletics, they actually need antiseptic material in order for them to run faster, to perform better. Even in sports equipment, nowadays, even a tennis racket, it can be built using carbon nanotubes, which is 100 times stronger than steel, and it's lighter. That's why they need it for their athletics. And if you have heard of quantum dots actually are referring to 2 to the 10 nanometer of materials. This is something more advanced. And these particles are increasing sizes, and then we are actually looking at nanomaterials. All right. And this is the Kira attendance sheet for today. That's all for my presentation. Is there any question?
Okay, thank you. Yeah, that's all for it.